When we are solving logarithmic equations, we have to be able to extend beyond the simple logarithmic equation that we learned in our previous lesson. So we use properties in order to achieve the same result and be able to solve our logarithm equation. There are three properties that we're discussing in this class. The first is product property, the second is quotient property, and each of those represent their own skill in the scale. And the last one is the power property of logarithms. So each of these have an expanded form and a condensed form. For the product property, expanded form includes two logarithm expressions with the same base and they're joined by addition. So this is an example of what expanded form would look like for product property. Condensed form has one logarithm expression with an of number that can be broken into factors. So this is an example of a condensed form of product property. Remember, the base, when it's not written, is 10. Now to move in between these forms, that's what's going to really propel us forward and be able to solve logarithmic equations. You need to be able to move fluidly between one form and the other. And I'm putting an emphasis on being able to convert from expanded form to condensed form because that's the one that you're going to see most often in this course. But we're going to cover both. So a condensed form, if I want to move it to expanded form, I need to create two logarithmic expressions that have the same base joined by addition. So I have log base 10 and log base 10, and there's my addition sign. And your factors, remember those are numbers that can be multiplied together, are going to be broken up and given to each of my logs. So condensed form, and this is what expanded form of the same logarithm would look like. To move from expanded to condensed form, we will take each of these logs and condense them into one single log. That's why they have to have the same base. And the two of numbers would be multiplied together because they become factors in my new of number. Quotient property. Now if we think about what product means multiply. Quotient means to divide, so we're going to have division happening in here. Our expanded form looks very similar. Two logarithmic expressions with the same base connected by a subtraction sign. Condensed form, we're going to have one logarithmic expression. Our of number is going to be expressed as a quotient. That's division. We are going to put our emphasis on converting from expanded to condensed form, but we'll walk through both. So to move from condensed to expanded form, we will need to separate it into the two logarithm expressions with the same base. And our quotient will be broken up into separate logarithms. The first one needs to go from the numerator, and the denominator needs to go to the second one. To move from expanded to condensed, they both have to have the same base. And remember, ln just means natural log, and it has a log base e that holds all the same properties. So I have the first one in the numerator, and the second one goes to the denominator. Now, power property does not have its own skill per se, and it's woven throughout the different equations. So power property, they both have one logarithmic expression for expanded and condensed form, but expanded form will have a coefficient. So whenever you see a coefficient for a log, it's expanded form of the power property, and condensed form will have an exponent on the of number. Now to move from expanded to condensed form and condensed to expanded form, both of those have an emphasis because you'll see both directions. But in converting from condensed to expanded form, we will have the exponent become the coefficient. And from condensed to expanded, or from expanded to condensed, we will have the coefficient become the exponent. Let's see what these look like when we are working through the problems. Now, when you see an equation like this, you are trying to meet one of two goals. You are either trying to have one log on each side of the equation that's all by itself. so that you can solve using your method from simple logarithm equations, where you take the of number on each side and set them equal to each other. Or you are attempting to have only one single log in the entire equation, and it has to be by itself, and you can switch to exponential form to solve. And when I say alone, what I'm meaning is that there's nothing multiplied, divided, added, or subtracted to the log itself. You only have the log, the base, and your of number. You may want to pause the video to write this down. So this first problem here, I see evidence of the quotient property. I know this because I have a subtraction sign in the middle of two logs with the same base. So I need to take that expanded form of the quotient property and make it into the condensed form so that I can work to achieve one of the two goals that we wrote down. So if I'm working with two logs with base 4, I'm going to make one single log with base 4, and I'm going to need to make it into a quotient. 48 is the first number, so that's my numerator. N is the second number, that's my denominator. And it equals log base 4 of 6. Now that I have one log on each side and it's alone, I have that first goal met. So I can set my of numbers equal to each other. And solve this just like we've been doing all along. So I'm going to multiply by n on both sides because I can't have n in the denominator. And that will give me 48 equals 6n. And then divide by 6 on both sides so that n is equal to 8. Now you always want to check that to make sure that you have no negative of numbers. So if I plug 8 in, it's still a positive number. We also can't have 0 as an of number as well. Plugging in 8 here doesn't give me 0 in the denominator. So 8 is my solution. It's not extraneous. There it is. Now number 2 looks very similar, but the difference is that it's two logs that are separated by an addition sign. So that's evidence of the expanded form of the product property. So I need to condense those into one single log. And their of numbers will be multiplied to x times 7. And it will equal my log base 3 of 28. Now that my logs are alone on both sides, I can set my of numbers equal to each other. 2x times 7 gives me 14x, and it equals 28. Divide by 14 on both sides, and x is equal to 2. Plug that 2 back in, make sure that I don't get 0 or a negative number. 2 times 2 is 4, so I'm positive. It's not extraneous. There's my solution. Number 3. Now, number 3, it looks to be like I have a simple logarithm equation, but there's one issue. I don't have a log that's alone on the left side. There's a number that's being multiplied in front, a coefficient. That means that I need to use the power property in order to simplify this before I can use simple logarithms to solve. Remember, when we have a coefficient, it becomes the exponent of my of number. So log base 2 of x cubed equals log base 2 of 8. Now I have one log on each side. They're all alone. I can set the of numbers equal to each other. So I'll take the cubed root to solve this. Cubed root of x cubed is x. Cubed root of 8 is 2. And check to make sure that I don't have a negative or 0 for my of number. 2 in for x, we're good. Number 4, I have a plus sign separating out these two logs base 10. So I'm going to use the product property to condense them into one single log. And I'll need to multiply the a times a minus 6. Now, I don't really need to write this base 10 because remember, if it looks like this, we assume that the base is 10. You can write it or don't write it. It doesn't really have a preference that I'm expressing here. So I have one single log, and it's all alone on this side. I'm going to take a second to simplify this here just so it looks a little simpler. And simplify. So I have one log all alone in the whole equation. It's all by itself. So that's our second goal that we could use, which means that we would need to use our loop or rewrite it into exponential form some other way. But we have base 10, our exponent is 2, and the number we're trying to get to is a squared minus 6a. Now 10 squared is 100, which means I'm going to be dealing here with a quadratic equation. I need to subtract that 100 from both sides. And try to solve it. Our first go-to usually is factoring because it's quick and easy. So if I were to try to factor this, here's all the factors of 100. And I need to make the larger factor negative so that it can meet my sign requirements. And unfortunately though, I don't see any of these that are going to add to equal -6. So I need to use another method of solving a quadratic, like the quadratic formula. So we'll have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. I need to take and find the discriminant. That means I'm plugging into my calculator. -6 squared minus 4 times 1 times -100. And I get that x equals 6 plus or minus the square root of 436 all over 2. Unfortunately, 436 is not a perfect square. If it was, we would have been able to factor. So I'm going to need to take 436 and do a factor tree. So I have 2 and 218, 2 and 109, and 109 is prime. So 2 comes out, giving me x equals 6 plus or minus 2 square roots of 109 all over 2. I can reduce, because 2, 2, and 6, I can reduce all of those by 2, leaving me with 3 plus or minus the square root of 109. Now check, make sure that I don't get a negative expo or a negative of number. So we'll have 3 plus the square root of 109. Okay, that's positive. And if I did that minus 6, I still have a positive number. Let's check for 3 minus the square root of 109. Uh-oh, that's negative when I plug it in. So I can only include the positive value. X equals 3 plus square root of 109. Let's take a look at the next one. I see a plus sign in the middle. So I know that I'm going to be using product property, but I can't quite use it yet until I deal with this 4. Power property needs to happen first. So we'll take the 4 and make it an exponent, giving me natural log of x plus natural log of 5 to the fourth power equals 2. 5 to the fourth power is 625. Now I can apply my product property. So I'll condense it into a single log, and I'll have 625 times x. And I've met my second goal. I can change this into exponential form. So the base is e, the exponent is 2, and the number I'm trying to get to is 625x. So I need to figure out what e to the second is. Second in the ln button gives me e to the second power. And we're going to keep this whole number in my calculator. And I'm just going to write down the first few digits just to remind me what number I'm working with and kind of show the path that I took to get to my answer. Next, I need to get this x alone. So I'll divide by 625 on both sides. So divided by, and it went ahead and plugged in that whole answer, 625. Gives me x is equal to 0.0118. We generally like to go to 4 decimal places.
For number 6, we don't have any product or quotient property to apply, but I do have a coefficient in front, which means I have expanded form of the power property. So I'm going to take that coefficient of -4, and it becomes the exponent of my of number. Now it has to become the exponent of the entire of number, not just the x. So we will have natural log, which remember is log base e, of 2x to the -4 equals -2. Natural log, and that -4 will need to be multiplied by each of the 1 exponents inside of the parentheses to give us 2 to the -4, and x to the -4 equals -2. -4 means to become positive by crossing over the fraction bar. So 2 to the -4 will go to the bottom, and x to the -4 will go to the bottom. And when that happens, they'll become positive, and we'll need to have a 1 to hold the place since there was nothing left on top. We can type 2 to the 4th into our calculator, and we get 16 x to the 4th on the bottom. And at this point, we have our second pathway or second goal met. One single log all by itself on one side of the equation. I can switch into exponential form. So I have log base e for natural log. So e to the -2 equals 1 over 16x to the 4th. So we'll use our calculator to find e to the -2. Second natural log button gives me e to the -2, and I get 0.1353. Then we need to raise each side to this, not raise it to a power, we need to multiply both sides by 16x to the 4th to get this x to the 4th out of the denominator and get rid of our fraction while we're at it. So I'll keep this number in my calculator so that I can multiply it by 16, and that gives me 2.1654 x to the 4th equals 1. Then we need to divide 1 by that long, nasty decimal. Whether it said 2x equals 1 or 2 0.1654 x to the fourth equals 1, we still do the same process to get x alone. We divide on both sides. So I have 1 divided by, and if I want to get this number up here, I'm going to press the second and the negative button next to the decimal down at the bottom to get A and S and use that previous number in my calculator. So x to the fourth equals 0.4618. To get rid of something to the fourth power, we'll need to take the fourth root of both sides. So x will now be alone. And since I took an even root, I need to put a plus or minus sign in front of my answer. And if your calculator requires you to type the index first, make sure you type the 4 first before you press math and option 5. My calculator does not, so I can type the 4 afterwards. And then I need to use that A and S again. So second and the negative button gives me 0.8244. We need to check both of these answers to see if one of them is extraneous. I do that by plugging it back into the original problem. So if I plug in a positive number in for x and multiply it by 2, I still keep a positive number. If I plug a negative number in for x, then I have a negative of number, and that's a problem. So we're going to keep just positive 0.8244. For the next one, I don't have any power property that I need to take care of. All I need to do is apply my product property. So natural log of 2x, oops, my pen's running out on me, so I'll switch pens here. Natural log of 2x times my 3x equals 9. So 2x times 3x gives me 6x squared. Now my natural log's alone, so I can convert into exponential form. So the base is e, the number is 9, and I'm trying to get to 6x to the second power. So on my calculator, I'll type e to the ninth power, 8,103.084 equals 6x to the second. Then we need to divide both sides by 6. We have 1,350.514 equals x squared. Then we'll square root both sides. And second and the negative button calls that entire number up there. We're going to put a plus or minus sign in front of it. So we have plus or minus 36.7493. And let's check to make sure that this isn't going to be extraneous. Positive 36 into here gives me a positive number and a positive number. Negative 36 plugged in for x gives me a negative of. So I want to only include positive 36.7493. Last one. Good job sticking through this to the end. Now we're going to keep this 2 where it is. So I'm going to need to change this into exponential form because my log's already by itself. So I will have natural log is log base e to the 6th power, trying to get to x plus 5 squared. So e to the 6th power gives me 403.42 8 equals x plus 5 quantity squared. Now we need to square root both sides to get rid of this square. And whenever we square root both sides, we have to put a plus or minus in front of it. We're going to use that A and S button second and the negative button. So plus or minus 20.0855 equals x plus 5. Now this plus or minus, because I'm going to need to subtract both sides by 5, I need to actually split this into two separate equations. We have positive 20.0855 equals x plus 5, and we have negative 20.0855 equals x plus 5. Because when I subtract 5 from both sides, I will now get two different numbers. It's not the same as just multiplying by a number. So I will have 15.0855 equals x, and on this side, subtracting 5 from both sides will give me negative 25.0855. Now, when I plug them back into the original problem, I have this getting squared. And we know that whenever we square a number, it doesn't matter if it's positive or negative, I always end with a positive number. So I have to include both answers as solutions.